Find the volume of the solid generated by revolving the region bounded by y equals cosine of x. Check. X equals 0. Okay, that's the vertical axis. Y equals 0, that's the x-axis. And x equals pi over 2. Okay, that makes sense because cosine of pi over 2 is 0, so it goes down to 0. Okay, seems reasonable. So this is a fairly straightforward disk method. Is it disk method? I think it's disk method. We're going to go with the disk method. Well, there's a disk drawn here, so it's probably disk method. Okay, so we're going to start by doing an integral from 0 to pi over 2. And I'll do pi r squared delta x. So the idea here is I want to find r. Ooh, I can draw r right here. So r would be, nope. There we go. Right, pen, here. Or right here. That's probably easier to draw. R. And so r then would equal cosine of x. I'm going to get an cosine squared. Cosine squared of x. And yep, we plug that in and solve. So the hardest part here is going to be finding the integral of cosine squared of x, which we can do. We just don't want to do. Okay. 0 to pi over 2. Move the pi out. Get a cosine squared of x. And then the delta x becomes dx. Okay. So now we need to remember our half angle formulas. So we got something kind of like, let's see if I can remember this. So we have 2 cosine of alpha, cosine of Bravo. I guess that's probably more of a beta. Beta? Yeah, beta makes more sense. It's okay. Not important. Cosine alpha minus beta plus cosine of alpha plus beta. Okay? And then the mnemonic I use, so I just memorize this. Straight up memorization. No tricks, no flair. Just brute forcing penguins onto the iceberg at gunpoint. So we have 2 sine of alpha, sine of beta. And then when you have sines instead of cosine, you just change the sign. So we have cosine alpha minus beta minus sine alpha plus beta. Ooh, cosine. There we go. Plus beta. And then when you have one of each, you have 2 sine alpha cosine beta. That's when you switch from, you go back to the original format, but you do sines instead of cosines. And that's just a mnemonic that I use and I find useful. So the way I do this is, this, memorize. This one, you switch from cosine to sine, so you change the sign. That's just mnemonic, not actual, real mathematical rigor. And then for this one, to have one of each, you write the sine first, and then you do the cosine, and then you go back to the original, and you change from cosines to sines, because you have one of each. And that's, I just memorize these. These are useful enough for enough applications that it's worth memorizing. So your first thought is, well, how do we get the cosine squared x to something else from here? Well, we use the first one right here. So we use that. So we say, all right, what if alpha equaled beta? Then we'd have 2 cosine squared of x equals cosine of alpha minus beta, which are both the same, so it'd be cosine of 0, plus cosine of 2x. So then we could rearrange this as cosine squared of x equals 1 of, what's it, cosine theta plus cosine of 2x over 2. And this is the formula then that we would use. Whoop. I'll put this over here for now. And so these are the formulas that I just have memorized. I'm going to erase them, though, just to keep the clutter down on the board. Whoop. There we go. Take just this portion right here, move it a little bit less sideways, get out my pen, do one of these numbers, 0 to pi over 2, pi dx. Okay, so now this is what we're going to be dealing with. So we converted this to this. Is that a double angle formula, half angle formula? I don't know. I just memorized the three equalities that I wrote down, and then I used those as appropriate to plug in the values. Okay, so now we're going to have to simplify this a little bit. Well, we don't have to, but it's probably easier if we do. So take out the 1/2. We have 1 plus cosine of 2x dx. This then is pi over 2 x plus, and then cosine of 2x will go to sine of 2x over 2. And then, so if we look at this, if we took the derivative of sine of x, we know we'd get positive cosine of x. Right, because the derivative of sine of x is positive cosine of x. And so when we take the integral of cosine of x, we'll get the same sign for sine of x. So that the sign on that is correct. I always like to check to make sure I get the signs correct on when I take the derivative, or especially the integral of cosine of x and sine of 2x. It's just so prone to error. And then this divided by 2, what I really did there was I did the u substitution of u equals 2x, du equals 2 dx, and from there then solved the problem. Okay, so remove that. Let's see, do a little bit of cleaning, maybe just a little bit. Okay, so from here then we can solve from 0 to pi over 2, which is, okay, so we know that x, when it's 0, it's going to be 0. Sine of 2 times 0 will be sine of 0, which will also be 0. So this 0 is going to go away. And so we're going to be left with pi over 2 times pi over 2 plus, this will be sine of pi over 2, which is sine of pi divided by 2. And so because the 2 times pi over 2, which is pi, sine of pi is, look at the unit circle, pi is over here. The y value of that would be 0. So this will go to 0. And we are left with pi squared over 2 squared, which is pi squared over 4. Aha, even a possible answer. Pi squared over 4. Okay, backtrack because there was a crazy amount of stuff that happened there. So we're told, find the volume of y equals cosine of x revolved around the x-axis from 0 to pi over 2. Not too bad. Even gives us a little picture. Very convenient. Thank you. And we look at this like, okay, no big deal. We know what to do. So the real calculus part is just right here. So figured out the calculus, and then we have to convert cosine squared of x to, I guess, cosine without the square. So we do a, I guess, double angle formula, half angle formula, trigonometric identity. I have 3 trigonometric identities I memorize, and if you plug in alpha equals beta, then you get this cosine squared of x equals this. And this is the value I had. Those formulas are worth memorizing. I know, I hate memorizing, but it's part of life. Then we can take the integral. We had to do a small u substitution, but it was easy enough, I kind of did it. We verified that we had the correct sign with the integral of cosine of x. Plugged in the values, most things canceled out, some things didn't, and some things that didn't cancel out were pi squared over 4. And that was left with our answer. So that's how we approach this problem. This problem is about 20% calculus and about 80% trigonometry, but it's still the sort of thing you're going to come across a lot. And this will be almost less for an AP exam, but if you're taking like a college level calculus, this is going to come up a lot, and it's good to know. And you'll look like a superstar when you know how to do it. Okay, appreciate you coming along. That's how this problem is approached. Thank you much. See you next time.